understanding more about batteries and electric vehicles. Okay. About the session for today, normally I start with the one session where I first introduce the different types of energy systems, and which includes all energy systems, and then I narrow down to batteries in particular towards the end of the session. But in this case, considering that I am already late because of the yesterday we lost one day, I'm thinking of skipping the original introduction to basic energies and just directly starting with lithium-ion batteries. Of course, in this part, I will be giving you some basics of the lithium-ion battery itself. So it will not be like any part will be skipped out, but a general portion of energy systems that we are just. And in my previous experience with the students, I have seen from the feedback that the first session about the general energy is very boring. So, so I personally feel that it's better to directly start off with the main part, that is the lithium-ion cells and the parameters of lithium-ion cells, which might be useful for you in upcoming any part related to batteries, and you're like trying to apply for some job or trying to apply for some project which is related to batteries or working on batteries. You should have the understanding of a lithium-ion battery. So we can skip to that part. Okay. See, there are some messages in the chat box. Thank you. Okay. I hope my screen is visible.
Yes, sir. Yes, sir.
Some panels in this might be a little old. I customize the sessions for every batch, but this time I have not customized it. But it should not be a problem from the content point of view. But if there is like something which is up and down, I will just try to explain it, okay, verbally. All right, so let's start the session. That is the lithium-ion cells and its parameters. And before we directly start into any session for the next few days, I will always be having one initial, the beginning of the sessions where there will be some brief recap or some general points related to batteries, which may or may not be directly related to the session. Okay. In this particular case, it's just a basic introduction of electric vehicles, and I'm pretty sure that you guys have already seen this in previous sessions. Consider this just as a small recap that we are doing. Okay. So introduction to electric vehicles, and everybody knows at this point like what are electric vehicles, but more importantly, I'm going to talk about what are the basic components of our electric vehicle. That is, you can see this vehicle. This is when we were when the Nexon electric vehicle was coming out. This was the outline that was sketched out, and this is the actual powertrain of the Nexon electric vehicle. And you can see the important components here. This is the first component. This is the battery pack of the vehicle. You can see here, this is the motor of the vehicle, the main part for the powertrain. And you can see on the top, there are some boxes here. And these boxes are nothing but the supporting components, which are helping the powertrain and the battery. These are like the collectively a combined unit, which is comprising of a power distribution unit, charging unit, a converter unit, and that we will be just having a look in the next slide. So you can see that this is the breakup of all these components. This is the battery pack. This is the powertrain. This is the main motor, and this is a single-speed gearbox along with it. I have mentioned specifications just in case if anybody is particularly interested, but it's not necessarily required for us to go through. This is just a specification of the Nexon electric vehicle. But for any electric vehicle, more or less, this is how the main components of the electric vehicle will look like from powertrain perspective. This will be the source of energy, the battery pack. This will be the motor and the single-speed gearbox. Most of the electric vehicles will have single-speed gearboxes because we can control the speed of the motor directly. And then these are the other auxiliary components that will be along with it. So on the top, you can see this. This is the power distribution unit. The job of the power distribution unit is very simple. just to uh, ensure that all the power that is coming and going from the battery or to the battery, this supply, this is the distribution unit that transfer everywhere the power. You can see there's another small box here. This is basically an onboard charger. Your electric vehicle has a domestic charging unit, and that charging unit needs to be controlled by something. So that is done by this small box here. That is the onboard charger. We call it as OBC. And just below that, you can see this is another thing that is called as DC-DC converter. This is simply because you see your battery pack is having a very high voltage, about 300 to 350 volts of voltage is there. But your auxiliary components in the car, that is your headlights, your radio, your small electrical components within the car, they require a smaller amount of supply for their particular, for their basically for the operation. And this small unit that is called as DC-DC converter, it converts the high voltage DC current to a low voltage DC current. That's all. That's the only job of this small component, but it is a very important component. This is just the basic architecture of BEV. And as I said, probably in previous session, you guys must have already studied this through. And this is how a basic blueprint of battery will look like. You will have one high voltage battery, that is the main battery pack. There will be a battery management system which controls this battery. There will be a power distribution unit. So you can see the battery is directly only connected to the power distribution unit. Battery is not connected to any other components directly. So whatever supply happens, it happens through a power distribution unit. And the rest of the stuff is the thing that I mentioned above, the DC-DC charger, which goes from high voltage battery pack to a small 12-volt battery pack, which is in front, that you guys may know, which is already existing in the current cars. And the onboard charger, the temperature sensors, and the inverter unit that is connected to the motor. Normally nowadays, the inverter motor comes as a single unit. In our case, in our design, we used to call this as MCU, which is basically a motor control unit. It was basically, its job was to control the motor. It used to act like a motor or also like a generator. So we gave it a common name of MCU, that is the motor control unit, but more commonly it's known as an inverter. You can see some messages in the chat. Okay. One more thing that I wanted to cover before we start with the lithium-ion batteries, that the cost of running of the batteries. And this is one of the slides that I said that is not updated. I wanted to update it with respect to the pricings of India in INR values. And we had done this when we were working once in OEM, but the slide, I was not able to find a particular data online. So I had to do it myself, and I'm a lazy person, so I'm sorry. But yeah, more or less the comparison is straight up is similar. And you can see if we see roughly that what is the running cost of an ICE vehicle as compared to the running cost of an electric vehicle. So this is the breakdown, that it will take you like $25 to run 400 miles. If somebody can translate it in INR, that will be really good. And comparatively, it's only having around $8 for 400 miles. And this was more or less same to the cost comparison that we had done in India, which was somewhere around 6 rupees to 8 rupees were required per kilometer for ICE vehicles, depending on petrol or diesel. And for an electric vehicle, the cost was around 2 rupees per kilometer. So yes, the running cost of electric vehicles is substantially low at the expense of the initial cost, because as you know that the initial cost of the electric vehicles is high at the moment because of the high price of the batteries. And the high price of the batteries, I mentioned it because you can see the chart over the last decade is that the prices of the batteries have substantially dropped over the period of 10 years. So it started off around $1,000 per kilowatt hour. Okay. And now if you see every year, substantially it was reducing. It was around $137 in 2020. It was around $126 per kilowatt hour in 2021. This year, because of the spikes in the raw materials, the price did not reduce. It's more or less the same, around $125 per kilowatt hour. So, but it is expected to fall down under the $100 per kilowatt hour in the next few years, like 2 or 3 years. Okay, the target by Bloomberg NEF was around 2026 at latest. So we can see the prices are coming down, and if the trend continues and if the battery packs are substantially cheaper, then obviously the cost of your electric vehicles will be comparable with your ICE counterparts, and that's when it will be accessible to the common people. And the price of the cell itself is not the concern. It's the collective price. You can see that we have to put the cells into packs. We have to like join them together in series and parallel, and we have to make a battery pack out of it. And then this pack goes into a set of modules, and these modules make up the entire system. And this system may or may not require some sort of separate installation. And you see the cost of cell is something, but the amount of the pack, the amount of the system, it adds up, it multiplies based on what the particular application is. And the cost you see here, it may or may not be the same thing. So we have to reduce the costing at every stage. And I believe for this, there's a particular set of engineering branch which works on like cost engineering to specifically see that wherever it's possible, like we can reduce the cost without affecting the quality of the product. And in any OEM, not just for electric vehicles, but for your regular ICE vehicles or any other industry which makes products, it will always have its set of R&D engineers specifically working on products to see if they can reduce the cost without hampering the quality. So it's nothing new. It's just a thing that is now being used in batteries as well. All right, so this covers all the initial part about electric vehicles that I wanted to talk about, which obviously I have rushed a little bit since, as I mentioned, we skipped some part yesterday. But if anybody has any doubts on the system, on electric vehicle components in general, you can always like just, even now you can unmute and ask the question, or if you're not able to speak, you can drop a message in the chat box and I will explain it, okay?